This is Pops getting his shot for the day. Water. This is an L14-30R or 30C, depending on which one you read. It's a basic 220 generator plug. What am I doing? Well, I'm setting up a 220 extension cord, essentially. Small one for lightweight stuff. Got a couple of machines out there, welder, and I think can't remember the other one. But anyway, I wanted to build an extension cord for some things that I have, because I have one out there that's 12 gauge, I believe. I have to go check again. And then for short distance, it can carry a pretty good load. So it's one of those things where the shorter the cord, the heavier load you can run without so much resistance, and without resistance, or with less resistance is less heat loss. So it's kind of what I'm looking at here. The head resurfacer out there, I think now draws 12 amps or so under full load. Hit it under full load the other day. What did I want to do tonight? Tonight I wanted to talk because I was writing down some information on some projects I have coming up. One of them I just finished one with a blown fuse, which is kind of unfortunate because Kubota didn't label things very well. And then in the end result, it made us both laugh, the customer and me, because I sat there and said, well, your radio fuse is blown. That's where your control circuit for the cab is. Excuse me. He says, what? And I said, that's where your control circuit for the cab is. The radio fuse. Well, yeah. I tried explaining it to him before, but it didn't make any sense. So he just said, no, come on up and take a look at it. It's not working. So I get up there, change the fuses. Everything's working fine. What happened? Oh, excuse me. What happened was he turned the radio on. He blew the fuse before. That's what started the problem. And I had to go through the schematics and everything to figure out where the darn fuse was. Because I'm looking at everything's fine. Who cares if the radio doesn't work, right? So I go through checking relays and say, wait a minute, the system's supposed to work. Check my schematic again, go into the fine detail. Pretty sure I had a bad relay, but even without the bad relay, it was a blown fuse. So it blew again. He turned the radio on. So, one of those things. And the funny part was for me was I had part of the system working without changing the fuse. That was the weird part. This time it had to have that fuse to even think of working. I don't know why. So anyway, that project's done. I've got another one here. A couple of them that, well, let's just say it's one of those things where they're not complicated, but they aren't simple. I know that sounds like a double talk, but it's not. It's kind of like, who was it, John Ratzenberger there in the movie What If? He said, that's not simple. He said, sure, it's simple. It's just hard. Anyway, what I want to talk tonight about was because the diesel transfer pump was something that came in, and I started looking through the manual to see what's there and what we're doing. And because I tend to be like that, if I don't have a manual, I kind of feel naked. And there's some tractors I don't need the manual for, but not that many. I've got so much stuff that I've done over the years that, please. It's like I told somebody one time, I said, I've worked on electric extruders, little plastic welding for the membranes, and well, it's not even plastic. That's kind of a, well, whatever, bituminous. That's a welder to weld the mats together for the fracking water ponds. I worked on those right on up through to the pipe welders, that weld the 6 and 8 and 12-inch pipe together. Worked on those, the heaters for them, right on up through to, I think, a 500 horsepower, 600 horsepower diesels. So, not much for the 500 and 600 horse. Once you get under that, oh yeah, worked on a bunch of them. Well, wait a minute. Yeah, 5, 5 1/4, and 14s. I worked on a few of those. More than a few. Dang, they were fun. But anyway, it caught me tonight that I figured I'd start anyway talking about some diesel injection pumps. Some of their peculiarities. One of them goes way back on John Deere that they did some oddball stuff. The Rosa Master systems that John Deere actually had their fingers into, and they kind of like Sears and Tecumseh, Sears and Roper. Sears would design the unit, hand it to those companies to build it for them, and the companies would build it for them dirt cheap. Then Sears had to warranty it because it was their design. And both companies did the same thing. They took their basic unit and made some changes to it for Sears. Rosa Master did that for John Deere with some of their pumps. They used to have little section pumps. The governor was in the engine, and it was not reliable. And the pump was this little turd, because all it was the main body of the pump. The rack controls and the governor and throttle, everything were in the block. Excuse me. Later on, they had a changeover of the system, and you were able to put a standard old Rosa Master pump in there. Well, Rosa got bought out by a company called Stanadyne, and so it had been Stanadyne for many, many, many years, and now a company called Delphi, which used to be connected to General Motors. The General Motors Delphi plants many, many years ago for electrical and accessories and parts and such. Well, now they own the rights to this pump when they build it, so you can get it saying Delphi. In fact, the fuel transfer pump I'm talking about was there. So one of the things I wanted to talk about with that pump is the injection pump. The old style was called a DB, and it was completely mechanical. It had a triangular top on it, very similar to an English pump that we won't get into. And on top, the later ones had 2 terminals for electric shutoff. One was a brass or copper strap that was the ground, and the other one was your actual connection. We'd get bad connections on those now and then. Not very often, but often enough. On top also was a return valve. It wasn't even a check valve. It was to cause back pressure in the body of the pump. As more fuel returned, it would build up pressure in the upper governor part. And it was to keep air out, and if there was a little bit of air in there or the fuel got warm, it was to keep gentle pressure on it so that the air could get out and go to the tank. It wouldn't cause trouble inside the pump. And so the pump had a couple of stages within it. Now on the back side where all the injection stuff is also the inlet port from the tank or transfer pump. When it comes in there, there's a vane pump. I think almost all of them were metal vanes. And also there's a regulating valve in there. That regulating valve is almost, how can I say, it regulates the basic minimum pressure for transfer into the pistons. But also inside there was the body of the pump. Down at the bottom of there's that round nub just hanging off the bottom of the pump that's an advance. Some advance has an electrical connection to it to keep it retarded at certain times. And I forgot what the other part was, but that's the main thing, was that it would either retard or advance, and some of it by the electrical. How can I say it? Yeah. Some of it would, and then I don't remember the specifics, but there were 2 types. There was a built-in and done, that's it. Some of them were basically, you fire up the engine, snap, it goes to full advance. And others had a nub on it for adjusting the pressure. The pressure spring, because the body inside the pump, the more fuel that transfer pump moved, it would build up inside there and it would change that advance. Faster the engine ran, the pressure inside the body of the pump going to the pistons and such, and the lubrication of the head would build up. Well, it'd get down in there and move that advance back and forth, your cam ring. Because what this had was a shaft that went through, drove a head in the middle. The head had rollers and plungers, and the cam ring around the outside, and the rollers ran inside the cam ring to push the pistons in and out. The pressure from the transfer pump pushed those pistons out so that they could even fill up. And then when they come around at the right time, they turn and align with one of the ports going back out the head to your injector. A couple of peculiarities was in the back. Your transfer pump had some sort of a regulating valve. And I do believe the regulating valve was one of those where it regulated basic minimum pressure in the pump to be sure the transfer pressure going to the pistons was there, but also that, as I believe it was kind of a spring-loaded, but had ports on each side so that it would allow the pressure in the body to go up so that it would run the advance. Now, whatever was left over from all of that to bleed off and to return to tank that it wasn't even used went up through the governor body, kept that all nice and lubed. And then your throttle shaft and shutoff shaft, if it had one, would often leak around the O-rings there. And they were, one went inside the other. But the return valve on top, it was a glass valve, and it was a check valve with a very fine ball. It was only supposed to hold back maximum like 10 or 15 pounds. Not much. But it had a notch in it, so at low RPM it was just sending fuel back. And as fuel sped up and would churn more and cause a problem with cavitating or air braiding, getting air spinning around enough that it would actually take air out of the fuel itself, because there's always entrained air in there, and cause trouble. No, that was designed to return it and then put just a little pressure on there, so as things got hot, it would keep it from percolating internally. That valve was known that there's a nylon alignment sleeve of some sort inside the pump itself that comes apart. Now, I can't remember if it's in the transfer pump or in the governor section, but in there was a nylon or brass or nylon sleeve, and pieces would come off as the pump got 3, 4, 5,000 hours or better. And we used to have dirty fuel. The thing would wear itself out and just start sloughing off and plug that return valve. When it did, the upper body of the pressure came off, screwed up the regulating valve, shut everything off. Just poof. Then you'd wait, come back a half hour later, sometimes even 5 minutes, fire right up, take off again. Sometimes all day, sometimes 30 seconds. So that's one of the problems. The other one is back in the head. There's a regulating valve inside the inlet. That regulating valve was known for sticking, and you'll need a breakdown of that. So, and this is on the Rosamaster DB, Rosamaster stanadyne delphi DB pump, old mechanical. And those are the main problems they used to have with it. Leaks in the shaft, problem with the regulator coming in. Some of them actually had a screen in the inlet that would plug, something else to check. Now, your transfer pressure coming from your tank isn't so critical. As long as fuel gets to the inlet, it can be 0 or 1 psi. As long as it gets there, the pump will take care of itself. It doesn't do well with vacuum. You say, well, it's a vane pump. Yeah, but it's a vane pump that builds pressure, and that means it's not good at vacuum. All right, it's time for me to go. Almost dead on the mark. So those are the main things to watch. And air gets in there. The thing doesn't bleed well. And another one to remember with this particular pump, and the British one, and we'll talk about that one later because it's very, very similar. Crack one line at a time to bleed air. You'll see some of these sometimes. They have a little T on them. And it's a high-pressure T. It'll handle the pressure of that thing that's up to 10,000 psi. Well, and you say the nozzles only pop at 3,000 or 2,500 or 2,000. Some even 1,500. Yeah. But when it's running under full load, the pressure goes sky high. Yeah, it pops at that pressure, but there's so much fuel trying to go through there, that little pintle goes way back. Fuel has to go through all those little holes and atomize. So the faster you go, the cleaner you can burn. Unless you're overfueling, of course. But, so you can be up 10, 12,000 psi from a nozzle that's popping at 2,500 or 3,000. It's not common. It's usually 2 to 3 times, so you'll be up around 8, 9,000 anyway. But under full load, you'll get surges of 12,000, 10,000. Yeah, on that pump. It's one of the things that wears it out. Fuel has to be clean. And your injection nozzles, you need them clean because that'll cause a problem with backup residual pressure in the pump. There's a lot of things that can go wrong with this pump with age. When they first fire up, they work great. It's simple, it's inexpensive, and it's easy to rebuild for the guys because basically if it's a moving part, Woohoo! Get a new one. So, but the main problems are your transfer fuel coming in has to be fast enough. It doesn't need pressure, but it can't have vacuum to survive. It needs fuel that flows fast enough. It'll draw some, but that's why you'll see most of them have a 3/8. Most of them have a 1/2-inch steel line coming to them. The 1/2-inch external, that is, but still, they'll have little rubber grommets. They go bad. They have to seal. The steel line, with a new grommet on it, steel line is already compressed. That grommet may not squeeze enough. So those are things you have to look at as far as air leaks. And some guys give up and just run a rubber line. It's not on a suction system, not ideal. You say, well, it's gravity. Yeah, it's gravity, but. And if you're going to do that, you want to run a 7/16 hose. But stay with your steel lines, at least 3/8, probably up to 1/2 inch. Nice big old line coming down in there, free flowing. As much as you can with a good filter, and it'll take care of itself from there. Once it gets in, you got your regulating valve. Your distributor head has a hard time getting rid of air, and then because of the pistons opening and closing, it may, well, I should say, pumping in and out. The pump out pressure going to 1, but if they're all open, it can suck air back in as the pistons are turning. That's why they say just crack one at a time. So crack one, get some fuel, close it. Crack another, get some fuel, close it. Crack another, get some fuel, close it. On your injection lines, even if it's on the head itself. And you only need 1 or 2 pistons up on the engine to bleed them out. 1 or 2 lines up there to bleed them out on a 4-cylinder to get it going. And even a 6, sometimes you just get 2 cylinders firing and it'll go fast enough to take care of itself the rest of the way. But if you can get to all of them, yeah, crack them one at a time up there. Get the lines cleared out. They'll fire right up and run good. Then it clears up fast. So that's one. You know, your shaft. I just told you your shafts leak. Sometimes your timing leaks. The return valve plugs. But the pumps also have these funky seals in the shaft coming in. They're cup seals, one this way and one that way. One to keep pressure in and the other to keep motor oil out. Well, motor oil has been known to migrate into the pump. But usually it's fuel getting past one, blowing right into the crankcase. So if you got one that's, all these old dogs is gaining oil, well, that's what it is, and don't mess with it. The diesel fuel in the oil doesn't hurt much. But if you run it long enough, it will start wiping things because there's no oil film. Diesel fuel's oil. Well, it's fuel oil. It's too thin. And you'll get bearings shined up. It'll take a long time, but you can toss a rod with one of these if it's leaking. So that's the most common thing. Gear loosening up in the front. Some of these pumps, most of them have keys. Some don't. Then you have to know for sure what your timing marks are. But most of them do have keys. So as long as your timing mark on the pump is lined up where it belongs, your gear hasn't moved, you got it. But you do have to, as the pump body turns, bring the thing up on your timing mark and stop. While you're stopped there, now go look at your pump mark. All there is a little etched mark to line up. And it'll make a difference moving it one way or the other. An Oliver oddity, because they put theirs on the opposite side of the engine for most of the other engine companies, their timing window is end of timing. So while everybody else may have 15, 20, so many degrees on the flywheel, yeah, Oliver will have 2, 4, 0, 6 after top dead center. End of injection time. Actually, it's 2 degrees before top dead center, some of them. But you'd say a lot of them were designed to, you put it at the end of injection, is right at the line, is, say, 4 degrees. And what they used to tell me at the injection shop was retard the timing to 2 degrees. Well, think about it. It's the end of injection. Yeah. That's 2 or 4 degrees before top dead center. End of injection. And they would say, bring it up 2 degrees. I started thinking about it one day. And if it's after top dead center, which I'd have to go back in the book to look, 4 degrees after top dead center, you back it up to 2, you're advancing the timing 2 degrees. And he said it would bring that engine alive. So just something to think about on that. Those are the most of the common problems. When you're timing them, most of the pumps are slotted. The later ones, don't use banjo fittings. They're fittings direct out of the head, and the head's bigger, heavier. It'll take the higher pressures of the injection nozzles at 4,500 psi, a lot of them. Then they burn cleaner, some of the later model Alice Chalmers on that pump. So that's a difference with them too. But as time went on, they changed over to another one called the DE pump that John Deere uses almost exclusively, which is an electronic pump controlled by a little module on the engine. Well, I'll catch up with you on that one later. Now, you say you didn't get specific. You didn't show pictures. That's correct. Why I refuse to do that in a lot of these discussions is to talk with you about your pump on your machine. And then you need to go to the book. You need to go to the book. I can show you a picture here. It isn't going to do you any good. You need to read that manual. You need to have a wrench in your hand, and you need to be doing the bleeding, the troubleshooting, the fuel changing. Otherwise, my discussion's a moot point. Even if I had the pictures and the board and the whole 9 yards, doesn't do you any good. On me doing it, but it does when you do it. Farm manuals, Farm Manuals Fast or something like that. That's one I just downloaded a owner's manual from now, I think 40 or 50 bucks. Complete, I should say, service manual. Time for me to go. You folks have a good night. Be good, behave, and be decent. This is November 2023. Peace out.